Hello students, welcome to the lecture series of conventional and non-conventional sources of energy. In the previous lecture, we discussed about the energy scenario in the world, energy scenario in India, and why we need a renewable energy for the future load demand. Okay. Now today our topic is economics of power generation. So let us begin. So first of all, we start with the load curve. The curve showing the variation of load on the power station with respect to time is known as load curve. We know that the load is nothing but the consumer end. In the power system, there are basically four main components. One is generation, second is transmission, third is distribution, and fourth is energy consumption, that is load. Okay. So on the consumer side, on the load side, the load is not fixed, load is not a constant, it is variable. Means load is changes continuously as the time changes. Suppose if we take the example of our home. In our home there are so many bulbs, so many fans, okay, TV, there are lot of electrical appliances, but means every time we can't switch on all the loads. We may means depending on the requirement we can switch on or switch off the loads. Okay, the load can vary continuously with respect to time. Okay, similarly in the industry, depending on the requirement, depending on the demand, okay, the load can vary. Means in the industry most of the work is possible on the or complete by the by using motors. Okay, so we can switch on or switch off motors depending on the requirement. In the power plant, depending on the power demand, okay, the generators can be switch on or switch off. So the load is not a constant, it is a vary with respect to time. Okay, and if we draw the curve in between the load in kilowatt and time in hour, that gives a load curve which is called a load curve. Means the curve in between load in kilowatt and time in hour is nothing but the load curve. Now load variations during the whole day, that is in 24 hours, are recorded half hourly or hourly. Okay, basically we perform the on hourly basis. Okay, so are recorded half hourly or hourly and are plotted against time on the graph. The curve thus obtained is known as daily load curve. Okay, means if we plot the curve in between load in kilowatt and time in hour, then that curve is called the daily load curve. Okay, means if you consider the time slot of 24 hours, okay, and load in kilowatt, that will give a load curve graph. It shows the variation of load with respect to time during the day only. Okay, the monthly load curve. Okay, if we want to calculate the monthly load curve, can be obtained from the average of daily load curve. Okay, the monthly load curve can be obtained from daily load curve of that month. Okay, suppose we have to calculate the load curve of the December 2021. Okay, then we have to take the average of all the days from 1st December to 31st December of 2021, and if we take the average, okay, we can get the monthly load curve. For this purpose, average values of power over a month at different times of the day, okay, are calculated and then plotted on the graph. The monthly load curve is generally used to fix the rate of energy, and the rate of energy means the bill we get from the MSEB, that will be calculated from the monthly load curve. Okay, means it is the average of all the days in that particular month. Then if you want to calculate the yearly load curve, okay, so yearly load curve is again obtained by taking the average of all the month in that year. By considering the monthly load curve of that particular year, this yearly load curve Now this curve is used, yearly load curve is used to determine the annual load factor. Okay, means to calculate the rate of energy we have to use monthly load curve. To calculate annual load factor we have to use yearly load curve, and to get the maximum demand of the particular day we have to calculate, or we have to draw a daily load curve. So this is the example of daily load curve. Okay, here on the y-axis we take the load in megawatt. Okay, so here 2 megawatt, 4 megawatt, and on the x-axis we get the time in hours. Okay, starting from midnight 12 to again midnight 12. Okay, means in the midnight 12, let us say there is an less load. Okay, then it will be start increasing. Okay, from the 2. Okay, then 4 again increasing. Okay, say again at the morning from the 6 a.m. it will start at the peak point. Okay, means whenever at the morning there will be an peak load. Again, means at the 8 or 10 a.m. again it will be decreasing. Okay, again it will be start increasing in the noon. Okay, again it will be increasing, and it will be again increasing at the evening in between 5 or 4 to 8. Okay, and again after 8 p.m. again it is decreasing. Okay, so this is a load curve. Okay, so load is vary with respect to time. Okay, now the highest point. Okay, highest point will indicate the maximum demand in that day. Means here the highest point is at this. Okay, here this is nothing but the highest point of the day. This is called the maximum demand of that day. Okay, and what is the maximum demand of that particular day is 6 megawatt for the particular day. Okay, if it is at the, let us say 8, let us say 9. Okay, if the highest point is at 8 9, then it will be the maximum highest demand in that day. And the area, okay, area under this curve. Okay, this curve cover this area. Okay, and area under this curve will get the, gives the unit generated in that day by the generator. Okay, so area, what area represent? Area represent the unit generator per day. Okay, means you know, as per discussed in the last lecture, that the unit generated is equal to kilowatt hour. Okay, means 1 unit is equal to 1 kilowatt hour. Okay, so our bill, electricity bill is also is in unit. Means we say that in this month we consume 40 unit, 100 unit, 200 unit. Okay, that is unit. So 1 unit is equal to 1 kilowatt hour. Okay, means if a load of 1 kilowatt is operated for 1 hour, then we say that we consume 1 unit per at that time. Okay, so we just discussed the importance of the daily load curve. The daily load curve shows the variation of load on the power station during the different hours of the day. Okay, the area under the daily load curve gives the number of units generated in the day. Okay, means how much electricity in unit, okay, is generated by the generator, that will be given by the daily load curve. So unit generated per day is equal to area in kilowatt hour under daily load curve. Okay, so area in kilowatt hour means, so here, so in the y-axis it is in megawatt, or in the x-axis it is in hour. So area, let us say if you want to calculate the area of single box, if you want to calculate the area of this single box, here we consider this box, we have to calculate the area of this box. Now this box represent the square. Okay, so here the area of one box is equal to 2 megawatt. Okay, 2 megawatt. So 2 megawatt we require area in kilowatt hour. Okay, so 2 megawatt can be converted into kilowatt. So 2 into 10 to the power 3. Okay, 2 megawatt. This is nothing but the 2 into means 2 megawatt means 2 into 10 to the power 6. Okay, but we required in kilowatt. Okay, so 2000 2000 kilowatt means if we divide this by 10 to the, by 1000 we get 2 kilowatt means 2000 kilowatt. Okay, so at this point on the y-axis it is 2000 kilowatt. Okay, and on the x-axis the time is 2 hour. Okay, time is 2 hour. So total is 4000 kilowatt hour. Okay, total unit generated by the single box is equal to 4000 kilowatt hour. Okay, so 4000 kilo 4000 kilowatt hour. Okay, that is the total unit generated by the single box. Okay, so there are so many boxes. So if we calculate the area which represent the total units generated in that particular day, the highest point the highest point on the daily load curve represent the maximum demand on the station on that day. Okay, so highest point is this point will give the maximum demand on that day. So on this day the maximum demand is 6 megawatt. The area under the daily load curve divided by the total number of hours gives the average load on the station in the day. So if you want to calculate the average load of the day, will be calculate area in kilowatt hour. Okay, area in kilowatt hour as we calculated under daily load curve divided by 24 hours. Okay, so if we divide by 24 hours to the area, okay, here then we get the average load. Okay, because average load we required in kilowatt. Okay, and but the given in kilowatt hour, so we have to divide by 24. So hours getting cancelled, we get the area means average load in kilowatt. The ratio of area under the load curve to the total area of rectangle in which it is contained gives the load factor. The next concept is load factor. Area under the load curve to the means ratio of area under the load curve to the total area of rectangle in which it is contained gives the load factor. Okay, so load factor is equal to, it also represented as ratio of average load upon maximum demand. Ratio of average load upon maximum demand. If we multiply numerator and denominator by 24, so we get average load into 24 upon maximum demand into 24. So here we just multiply numerator and denominator by 24. So what we get, average load into 24 is nothing but the area in kilowatt hour under daily load curve. Okay, that is average load upon maximum demand into 24 is the total area of rectangle in which the load curve is contained. Okay, that gives the load factor. Then this is all about the daily load curve. Then learn about the some of the important terms which is required for the economics of power generation. So here first is connected load. What is meant by connected load? It is the sum of continuous ratings of all the equipment connected to supply systems. Okay, means for example in our home we connect, let us say, 5 bulbs, 5 fans. Okay, one TV, one refrigerator, one washing machine. Okay, this, if we calculate the load of all the equipment, then it is called a connected load. Okay, means here suppose we have 5 bulb. Okay, we have 5 bulbs. We have 5 bulbs of each of 100 watt, means total is 500 watt. Okay, total is 500 watt, let us say. Okay, then let us say one refrigerator. Okay, one refrigerator, let us say refrigerator, let us say is at 500 watt. Okay, then let us say one heater, let us say it is 1000 watt. Okay, then let us say two fans, let us say it is of one fan is of, let us say 200 watt, so total is 400 watt. So let us say these are the all the equipment in our home. Okay, so total load connected or total connected load is equal to, we have to add all the power rating of that load, means 500 plus 500, 1000 plus 1000, that is 2000, plus 400, that is 2400, that is 2400 watt. Okay, so this is the total connected load. Okay, but we can't switch on at a time of this all the load. Okay, we can switch on or switch off depending on our requirement. So that is nothing but the connected load. Connected load means we add all the power ratings of the loads connected to our home, connected to the industries, connected to the commercial shops. Okay, now, so it is the sum of continuous ratings. Okay, continuous ratings means 5 bulb, one bulb having a rating of 100 watt, then 5 bulb having a rating of 500 watt, one refrigerator having a rating of 500 watt, means continuous rating. Rating is nothing but the which is mentioned on the nameplate of that electrical device. The sum of continuous rating of all the equipment in the consumer's premises is the connected load of consumer. Example, if a consumer has connection of 500 watt lamps, okay, means total is 500 watt, and a power point of 500 watt. Okay, so 5 into 100, 500. Okay, and 500 watt of power point plus 500, so it is 500 plus 500, that is 1000 watt. Then sum of the connected load of all the consumer is connected load to the power station. Means in this way, if we sum all the loads of all the consumers, whether it is commercial consumer, whether it is residential consumer, whether it is industrial consumer, then it is the connected load to the power station. Then maximum demand, as we told, it is the greatest demand of the load on the power station during a given period. Okay, it is already shown on the that daily load curve, greatest demand on the particular day. Okay, during a given period, the maximum of all the demands that have occurred during a given period is the maximum demand. The knowledge of maximum demand is very important as it helps in determining the installed capacity of the station. Okay, the maximum of all the demands that have occurred during a given period, okay, is the maximum demand, as we discussed in the daily load curve. The knowledge of the maximum demand is very important as it helps in determining the installed capacity of the station. Okay, because from the maximum demand we can calculate the installed capacity of the station. Means in the previous daily load curve, the maximum demand is 6 megawatt. So station must have capacity to supply a 6 megawatt power. Okay, suppose the demand is, let us say, 20 megawatt, so station must have a capacity to supply a 20 megawatt power. Okay, so from the maximum demand we can calculate the installed capacity. It helps to determine the installed capacity of the station. Then next is the demand factor. It is the ratio of maximum demand on the power station to its connected load. So demand factor is equal to maximum demand, means maximum demand is the demand, particular demand on the particular period. Okay, is the means maximum demand in the particular period is the maximum demand upon connected load. Okay, so obviously connected load is always greater than maximum demand, because connected load is the sum of all the ratings of the load, and maximum demand is the particular demand on the particular day. So therefore the value of the demand factor usually less than 1, because we can't switch on all the load. Suppose in our home, can we switch on all the load simultaneously? Means bulbs, fan, refrigerator, heater, AC. Okay, means we can't switch on all the load. Okay, we will be switch on or switch off depending on our requirement. The knowledge of demand factor is vital in determining the capacity of the plant equipment. Means demand factor gives the capacity of the plant equipment. Then next is the average load. The average of load occurring on the power station in a given period is known as average load or average demand. The average of loads occurring on the power station. Average load already we calculate the average load, means average of loads occurring on the power station in a given period, okay, is known as average load. Average load means sum of all the loads in the all the hours, okay, in a particular day divided by 24. Okay, similarly for the months, means average of all the day in the particular month divided by total number of days. So daily average load is equal to number of unit in kilowatt hour generated in a day upon 24 hours. Monthly average load, number of unit kilowatt hour generated in a month upon number of hours in a month. Number of hours in a month means depending on the number of days. Suppose the month is of 30 days, then 30 into 24, that is the number of hours in a month. Then yearly average load, so number of unit generated in a year upon 8760 hours. So 8760 is equal to 24 into number of days in year, that is 365. If we multiply 365 into 24, you will get 8760 hours. Okay, so in this way we can calculate the average load. Then load factor, the ratio of average load to the maximum demand during a given period. Okay, average ratio of average load to the maximum demand during a given period is known as load factor. Load factor is equal to average load upon maximum demand. If the plant is in operation for T hours, load factor is equal to average load into T upon maximum demand into T. Okay, means if the plant is in operation for T hours, then load factor is equal to average load into T, means multiply by time upon maximum demand into T. So average load into T will be unit generated in T hours, means T is the particular time. Okay, means whether it is 4 hours, 5 hours, 8 hours or 24 hours. So it is average load into time is nothing but the unit generated in T hours upon maximum demand into T hours. So higher the load factor of the power station, lesser will be the cost per unit generated. Okay, so to get the lesser cost, we have to keep load factor as high as possible. Okay, because higher the load factor of the power station. Now load factor, when the load factor is higher, then the maximum demand will be lower. Okay, and when the maximum demand will be lower, okay, then the plant is capable to fulfill the given load. Okay, then so load factor will be, means we required a higher load factor, and hence the cost per unit generated will be less. Then next is the diversity factor, the ratio of sum of individual maximum demand to the maximum demand on power plant is known as diversity factor. Okay, the ratio of sum of individual maximum demand, okay, means let us say there are 10 consumers. Okay, they require the electricity from the generating plant. Now let us say one having a maximum demand of 1 megawatt, another having a 5 megawatt, 3 megawatt. Okay, so the ratio of sum of individual maximum demand. Okay, so always individual maximum demand is greater than maximum demand on the power station. Okay, so diversity factor is equal to sum of individual maximum demand upon maximum demand on power station. The diversity factor will always be greater than 1, because in if we observe the load curve, Okay, so let us say this is the maximum demand of one consumer, this is the maximum demand of another consumer, this is the maximum demand of another consumer. Okay, if we add the maximum demand of all the consumer, okay, and maximum demand on the upon maximum demand on the power plant, so total will be always greater than the single maximum demand. So maximum demand on power station, that's why the diversity factor will always be greater than 1. The greater the diversity factor, the lesser is the cost of generation of power. Okay, so greater the diversity factor, the lesser is the cost of generation of power. Means if the diversity factor is more, means maximum demand on the power station will be less. Okay, and if the maximum demand will be less, cost of generation will be less. Then plant capacity factor, it is the ratio of actual energy produced to the maximum possible energy that could have been, means it is the ratio of actual energy produced, okay, to the maximum possible energy that could have been produced during a given period. Means if we operate a generator for a 1 day, okay, then let us say capacity of the generator is, let us say 250 megawatt, okay, but we required, let us say 200 megawatt. Okay, so it is the ratio of actual energy produced, actual energy is 200 megawatt, okay, to the maximum possible, maximum possible means how much it can be produced, maximum 250 megawatt. So that represent the plant capacity factor. So plant capacity factor is equal to actual energy produced to the maximum energy that could have been produced. Okay, so it is equal to average demand into T upon plant capacity into T, or average demand upon plant capacity. So annual plant capacity factor. So annual plant capacity factor is equal to annual kilowatt hour output upon plant capacity into total time, that is 365 into 24. This is the plant capacity. Okay, and if you want to calculate the annual plant capacity of the power plant, then annual kilowatt hour output upon plant capacity, okay, into 8760, means 8760 is the 24 into 365 days. Then the plant capacity factor, but why we require the plant capacity factor, because is an indication of the reserve capacity of the plant. Okay, means from the plant capacity we can calculate the reserve capacity of the plant, and this reserve capacity will be useful in the peak load. Means suppose now there will be in winter season, okay, in the winter season there will be no need of AC coolers, okay, but in the summer season suddenly AC will be, AC and coolers will be started. Okay, so at that time we suddenly require the need of electricity. So at that time that reserve capacity will be helpful to supply the current to the particular load. A power station is so designed that it has some reserve capacity for meeting the increased load demand in future. Therefore, the installed capacity of plant is always somewhat greater than the maximum demand on the plant. Okay, because day by day the demand of electricity goes on increasing as there is an globalization is occurs, as there is industrialization is occurs. Okay, so demand is goes on increasing. So the here a plant will be designed in such a way that its reserve capacity, okay, will be more than the maximum demand, or the installed capacity of the plant is greater than the maximum demand. So reserve capacity is equal to plant capacity minus maximum demand. Okay, let us say 250 megawatt is the plant capacity and the maximum demand is, let us say 200 megawatt, then the reserve capacity is 50 megawatt. Then plant use factor, it is the ratio of kilowatt hour generated to the product of plant capacity and the number of hours for which the plant was in operation. Okay, means it is the ratio of kilowatt hour generated to the product of plant capacity, okay, and the number of hours for which the plant was in operation, that is plant use factor, is equal to station output in kilowatt hour, means unit generated, upon plant capacity, in megawatt in hours of use. Okay, means suppose plant having an installed capacity of 20 megawatt, means plant means generating plant. Okay, having an installed capacity of 20 megawatt produces annual output of 7.35 into 106 kilowatt. Okay, and remains in operation for 2190 hours in a year. Then means how much plant is used. So plant use factor is equal to this annual output 7.35 into 10 to the power 6 kilowatt upon this installed capacity 20 into 10 to the power 3 into 21, it is not 106, it is a 10 to the power 6, okay, into 2190, because plant is in operation is 2190 hours, so we get 0.167, means in percentage it is 16.7. So in that year plant use will be 16.7%. Now next is the unit generated per annum, means yearly how much unit is generated. It is often required to find the kilowatt hour generated per annum from maximum demand and load factor. To find kilowatt hour generated means in a particular year how much unit is generated. Okay, so load factor is equal to average load upon maximum demand. Average load is equal to from this maximum demand into load factor. So unit generated per annum is equal to average load in kilowatt into hours in a years. Okay, and average load will be maximum demand into load factor. So maximum demand in kilowatt, okay, into load factor into 8760, that is hours in a year, 365 into 24, that is the total unit generated per annum, that is the unit generated in a year. Now next is the types of load. Now load is the device which consume electrical power or which absorb electrical power, okay, to perform the particular task. Yes, a device which taps or consume electrical energy from electrical power system is called a load on the system. There are three types of the load basically. Load may be resistive, for example electric lamp; inductive, example induction motor; or capacitive. Capacitive means synchronous motor or capacitor, fixed or variable capacitor, or some combination of them, means combination of resistance inductance, combination of resistance capacitance, or combination of resistance inductance capacitance are also types of load. The various types of load on the power systems are, okay, the loads can be classified as, first is the domestic load, means in the domestic load consists of lights, fan, refrigerators, heaters, television, small motors for pumping water, that is single phase motor. Most of the residential load occurs. Okay, so these are the examples of domestic load. Most of the residential load occurs only for some hours during the day. Okay, means this load cannot be operated in all the times, it will be changes, okay, as per the times. Means we can't switch on the TV throughout the 24 hours. Okay, we can switch on it for the particular time in a day. Okay, fans, okay, we can't switch on fans in 24 hours. Okay, it may be vary as per the time and as per our requirement. Okay, lighting load occurs during night time, and domestic appliances load occur for only a few hours further. Okay, this lighting load will be occurs at night time, and domestic appliances load occurs only for a few hours. For this means as we can't operate the load continuously, hence the load factor is low in case of the domestic load, which is 10% to 12%. The next is the commercial load. Commercial load consists of lighting for shops, fans, and electrical appliances used in restaurant, etc. This class of load occurs for more hours during the day as compared to the domestic load. The commercial load has seasonal variation due to extensive use of air conditioners and space heaters. Okay, so this commercial load occurs for more hours during the day as compared to domestic load. Okay, we know that in a commercial load in the shops, the light, fan, ACs are switch on for the whole day. Okay, so it is more as compared to the domestic. Industrial load. Industrial load consists of load demand by the industries. Okay, the magnitude of industry's load depend upon the type of industry. The small case means in the industry most of the loads are the motors and equipment connected to the motors. Okay, the small scale industry have a load demand up to 25 kilowatt, medium scale 25 to 100 kilowatt, and large scale industry requires load above 500 kilowatt. Then next is the municipal load. The municipal corporation load consists of street lighting, power required for water supply and drainage purpose. Street lighting load is practically constant throughout the hours of the night. Okay, because street light once we in the night, you know, so municipal loads. Okay, so practically street lighting load is constant throughout the hours of the night. For water supply, water is pumped to overhead tanks. Okay, by pump driven by electric motor. Pumping is carried out during the off peak period, usually occurring during the night. Okay, so this is a municipal load. Then irrigation load. Irrigation load. This type of load is the electric power needed for pump driven by motor to supply water to field. Generally, this type of load is supplied for 10 hours during the night. Okay, so irrigation type of load. Then traction load. Traction load. This type of load includes tram cars, trolley buses, railways. Okay, traction, that is locomotives or cars. Okay, which depends on the electricity, that is called a traction load. This class of load has wide variation. Okay, so this is all about the today's lecture. So in the today's lecture we discuss the following points as load curve. Okay, daily load curve, monthly load curve, and yearly load curve. Then important terms and factors, that is connected load, diversity factor, load factor, maximum demand. Okay, then unit generated per annum. Okay, means how to calculate the unit generated yearly, monthly, and daily basis, and types of load. Okay, commercial load, domestic load, municipal load, residential load, industrial load. Okay, these all are all the topic covered today. Okay, thank you.